Now we're going to go over word problems. When they say angle of elevation, that means you are looking up at an object. An angle of depression would be when you look down at an object. So for example, I need to classify each angle in the picture. If I look at angle 1, here's the bird's perspective. It's a straight line. But if it looks down at the lighthouse, this is an angle of depression. Now, if I'm in the lighthouse looking out, if I look up at the bird, that is now an angle of elevation. Angle 3, they're looking down at this boat. This would be an angle of depression. Angle 4, here I am at the boat. Hopefully you're not down there. You look up at the lighthouse, which is an angle of elevation. So if you look down, it's depression. If you're looking up, it's an angle of elevation. Let's try a few more problems. A lifeguard is watching a beach from a line of sight 6 feet above the ground. So I'm going to draw, here's his line of sight. It is 6 feet above the ground. Here's the ground, 6 feet. He sees a swimmer at an angle of depression, which means he looks down at the swimmer. So he sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? Okay, so there's a few ways we can do this. If I look at this triangle here, I know this is 6. If this angle is 8, and I want to find this one, I'm going to do 90, because I'm going to use a rectangle almost, minus 8 to get the 82 degrees right here. If I want to find how far away the swimmer is from the tower, I'm looking for this length right here. I'm going to label it X. Now I'm just going to use this triangle that I drew like we did in the last examples. Here's my angle, opposite, no hypotenuse, adjacent. Tangent of 82 equals O over A. I solve it by timesing it by 6. Those cancel out, and X is equal to 6 times tangent of 82. 42.7. And what was our measurement? Feet. That's how far away the swimmer is from the tower. Example 6. A jet is flying at an altitude of 30,000 feet. That's how high they are. An air traffic controller measures the angle of elevation. So let's say this is the traffic control down here, because they're on the ground. An angle of elevation means that from their line of sight, this is going to be looking up at the plane at an elevation of 6 15.5 degrees. Find the horizontal distance of the plane from the airport. Horizontal distance. Now I have a triangle. I can do my trig. Opposite, no hypotenuse, adjacent. Tangent of 16.5 equals O over A times by x, cancels out, divide by tangent, that cancels out, gone. X is equal to 30,000 divided by tangent of 16.5, which gives us, all right, I'm going to write that down. 101,278.3, 101,278.3 feet from the airport. Example 7. A trolley car track rises vertically, vertical means up and down, 40 feet. Over a horizontal distance of 630 feet. What is the angle of elevation? Well, I'm just going to make a triangle with this. And they want to know the angle of elevation. There's my triangle. Opposite, no hypotenuse, adjacent. We're using a lot of tangents. O over A. Because I'm looking for the angle, I have to use the inverse, and it will go to the 40 over 630, and that'll give us our missing angle. Second tangent, 40 divided by 630 equals 3.6 degrees. Which makes sense because a trolley car should not go up at a huge degree or else it'd be insane. Example 8. Mary is flying a kite with a 50-meter string. Okay, here's Mary flying a kite, which are my favorite shapes. It is 50 meters. The string is making a 50-degree angle with the ground. So let's pretend that's the ground, 50-degree angle. Or you can extend it out and draw an angle that way if you want to. How high above the ground is the kite? So yeah, actually, I'm going to extend it. X. If we were measuring it for actually being on the ground, she would have to be laying down, but we're just going to do that because we don't know her height. Opposite, hypotenuse, is sine of 50 equals O over H. Times by the 50, and we get x equals 50 sine of 50 equals 38.3, and it is in meters. That is how high her kite is above the ground. Example 9. From the top of a lighthouse, wow, that's really bad. Pretend that's a lighthouse. Okay. top of a lighthouse that's 210 feet high. That's how high it is. The angle of depression of a boat is 27 degrees. From the top of a lighthouse, the angle of depression to a boat, here's my little boat. Depression means they're looking down, 27 degrees. 210, 27. I'm just going to find this so I can use that angle. 90, because it's 90 degrees in the corner, minus the 27 would give me 63 in this corner. Then I can use the 210. Find the distance of the of the boat to the foot of the lighthouse. The lighthouse was built at sea level, so it makes it easy. It's a straight shot. X. Angle. Opposite, no hypotenuse, adjacent. Tangent of 63 equals O over A times by 210, and X is equal to 210 tangent of 63, which gives me the boat is 412 feet from the bottom of that lighthouse.